Welcome all. Today I start a new topic, that is shear force and bending moment of beam. Before going to the shear force and bending moment, first we have to understand what is beam, uh, why or where this beam is actually used, and why this shear force and bending moment criteria is important in case of design of a beam. In our daily life, we actually see different structure, that is your some bridge or some uh, monorail line or some set of any workshop at different position. For construct a structure we use beam, and this beam, these all are the beams. Okay, this one is also a concrete beam, this one is a beam in a which is used to uh, actually uh, construct a bridge. You can see the lot of beams are used in a structure. These beams are actually used to carry the load. Now, what type of load is actually used in beam? We discussed this thing, and you can see that to design this type of structure, uh, we used the we use the beam. And actually that is why beam is very much important, because it actually carry the whole load, and therefore we have to design the beam very carefully, that what type of beam, and the dimensions of the beam is very much important. That is why when we design this kind of beam which is used in different section, we have to design it very carefully, and we have to obey some criteria to design this thing. That is why we can say after the design that it is safe to operate. uh, that is why we have to design this beam, and that section, that to design the beam, the shear force and bending moment play a vital role. Now first we have to understand what is beam. You can see the beam is a structural member which is long when compared with its lateral dimension, subjected to transverse forces so applied as to induce bending of the member in an axial plane is called beam. You can see in the previous picture that whatever the load uh, actually carry this beam, all the loads are transverse load. Transverse load means, if suppose we draw here one beam, that is, if this one is a beam, okay, then always here load is applied in transverse direction. Okay, and this beam is a structural member which is long with respect to the other dimension. It is 2D. If you draw the three dimensional, then it is like that. Okay, now what is the objective of the beam? When a beam is loaded by a force or couples, stresses and strains are created throughout the interior of the beam. We already know this thing, that if we apply any force or couples, then stress and strain are developed within the beam. Now, to determine these stresses and strains, the internal forces and internal couples that act on the cross section of the beam, cross section means this one, or if we consider this section, then we have to take this cross section. Okay, this cross section. Okay, So here we actually, to determine the stress and strains, the internal forces and internal couples that act on this cross section, if we consider this section, must be found. Now, in case of shear force and bending moment, these terms are very much important. First, we already discussed this thing, that is what is beam. Beam is a structural member which is subjected to transverse load. Now, what is transverse load? Transverse load is the load which is perpendicular or it has non-zero component perpendicular to the longitudinal axis of the beam. In our previous diagram, if we consider here an axis which is in the mid plane of the beam, okay, then with respect to this axis, these forces are perpendicular. That is your transverse load. Okay. Now, what is shear force? It is the unbalanced force on either side of a section parallel to cross section. Okay. If in our previous diagram, if we consider this cross section, okay, this cross section, then the load is applied here, which is parallel to the surface. Okay, is parallel to this cross section. Then what is moment? Moment, it is a product of force and perpendicular distance between the line of action of the force and the point about which moment is required to be calculated. It is already you know this thing actually. Now, what is bending moment? It is the unbalanced moment on the either side of the section in the plane of beam. When you consider a beam, then suppose in our previous diagram here, if we consider this section, then each side of this section, if we calculate the moment, then it is a bending moment. It is unbalanced moment, because here why it is bending, because if we apply a force here, then this beam tends to bend here. Okay, if we just consider by one line here, that is your central axis, then if before the applied load, if it is in this if this one is horizontal, then after applying this force, it tends to this bend. Okay, that is why the moment is bending moment. uh, Here it is an unbalanced moment on the either side of the section in the plane. We can calculate this bending moment in either side of the section, whichever which we have actually considered. Now, how we can calculate the shear force and bending moment? Basically, the shear force is the algebraic sum of the vertical forces acting to the left or right of the cut section. Whatever the section we actually consider, uh, about this section, the whatever it is, maybe on the left side of the section or the right side of the section, if we can consider only one side, then on that side the algebraic sum of the vertical forces is your shear forces. Okay. Now, what is bending moment? Bending moment is actually the algebraic sum of the moment of the forces to the left or to the right of the section taken about the section. Means, suppose here, first suppose I consider one beam. Okay, suppose this one is one beam. Suppose here we consider a simply supported beam. I will discuss this thing later, and that what is the simply supported beam. Suppose this one is simply supported beam. This one is the just free body diagram of the simply supported beam. Okay. Now, if here lot of forces acts, then if we consider only this section, then about this section if we consider, we have to calculate the shear force about this section, then we have to consider either this right hand side or this left hand side. Okay, now if we consider the right hand side, this one, then the shear force of this section is actually the sum of these forces, these vertical forces. We are not considering these forces. If we consider the left hand side, then only we consider these two forces, not these forces. Okay, and similarly the bending moment is also uh, we have to select in either side. Okay, if we consider this right hand side, then we have to sum up all the moments which is created due to these three forces. Okay, these three forces. If we consider the left hand side, then about this section, the bending moment is actually the sum of the moment which is created due to these two forces. Okay, now before uh, going to this, what the loads actually do, first we have to know that any structural member, that may be beam, is designed by two criteria. One is strength criteria and one is rigidity criteria. Now we discussed already that is beam is a long structural member with the dimension of its length is very much high, very much uh, larger in comparison to the other dimension, lateral dimensions, and it is actually it is subjected to a transverse load. Uh, this transverse shear load actually is perpendicular to the axis of the beam. Now this transverse shear load is causes variable shear force and variable bending moments. Hence, we have to know the variation of the shear force and bending moment over a length of the beam, and also we have to calculate the maximum values of the shear force and bending moment. That is why you have to draw or calculate the shear force diagram and bending moment diagram, and this shear maximum value of shear force and bending moment is used to in design the beam under strength criteria. Means if we consider the strength criteria and we have, if we want to design a beam under the strength criteria, then we have to know the maximum shear stress and the maximum bending moment value of the beam. And if we consider the rigidity or stiffness criteria, then the deflection and slopes are used in the design of beam. Okay, means if we consider the rigidity or stiffness criteria in case of design of beam, then we have to consider the deflection and slopes to design the beam. In our case, here we actually consider the maximum value of shear force and bending moment. Why we actually select this shear force and bending moment to design the beam under the strength criteria? Because there is a chance to fail the beam under this the shear force and bending moment. Okay, now you can see if we consider this kind of beam, then if we uh, actually if we apply a force here or load here, then this beam is try to try to bend, actually try to bend in this way, and that in this, and that is why it can fail under this deflection or this under uh, the shear force. Also it can fail, it can actually cut in this way if under the shear load. How it happened, I discussed this thing. Okay, and just you see, um, if we give a force here or load here, then the body tends to bend in this way. If it tends to bend or it actually bend in this way, then what happened in the upper portion above the neutral axis, um, it is in all the zones here, it is actually under compression, and the below the neutral axis all the zones are in tension. Okay, and if we can also fail by the shearing action of the load. Okay, how it actually happened. I discussed this thing in this video. uh, okay, 1 minute. You can see that this one is the example of the problem of the any shear force to calculate the shear force diagram and bending moment diagram. Okay, I discussed how this load is actually applied on the beam and how it may fail. Suppose this one is a beam. This one is actually the simply supported beam, where on one side it is pinned joint and in the other side it is the roller joint. I discuss this thing later, what is the pin joint and what is the roller joint. And suppose if this one is a concentrated load here, point load is applied here. uh, Now we see how the internal forces actually generated. If we consider this section, and with respect to that the applied load here, actually shear forces, internal shear forces created. Okay, and under this maximum, if it beyond the maximum shear stress it can withstand, then it can fail under this shear force or the shear load. Now what happened, we discussed this thing here, that if we apply load in this way, then this body, this beam, actually this beam tends to bend. If it bends, then what happened, if we consider a mid plane here, and if we consider the mid plane as the neutral plane, then above the neutral plane the beam at this section, the compression is actually acts, and uh, below the neutral axis or neutral plane, the here the tension is acts. Why? Because if we draw a beam here, okay, suppose we draw a 2D beam, okay, this is the two support, okay, and if we give a load, then this beam tends to bend in this way. If it bends in this way, okay, if it bends in this way, then at the tops, from the, if we actually considered the mid axis here, then above the mid axis this portion is under compression, and below the mid axis or neutral axis this zone is actually in tension. This zone in tension, this zone is compression. Here it is shown. Okay, now what happened, now due to this kind of variation in internal forces, okay, this one is compressive and this one is tensile. This here, due to this variation of these two type of forces, one moment is actually generated, that is bending moment. This kind of moment actually acts here due to this variation of the force. Then this one is shear force and this one is bending moment. Therefore, due to this transverse load, Here two type of internal forces, one type of internal force, that is shear force, and one bending moment, that one type of moment, that is bending moment, is actually generated due to the transverse load. And we have to calculate the maximum value of the shear force and bending moment all over the length of the beam to find where it can fail, or whether the design of the beam is actually safe or not. This one is a concentrated force, this one is a distributed force, which is distributed over a length of the beam, and this concentrated force is actually your point load, which acts on a point only, and this one is a concentrated moment, okay, where the moment is actually concentrated in a on a point only, okay. These are the different types of support. We discuss this thing later, okay. Now in case of design of beam under this strength criteria, the in architectural structures, bending moment is more important. Why this bending moment is more important? Because due to the length of the beam, the beam has the long enough, and due to that the bending moment, the value of the bending moment is very high, and therefore this bending moment is more important in case of the long structure, okay. And in case of short span structure with heavy loads, shear is actually dominant, okay. Now uh, we have to know the different types of support, because every beam has some supports, okay. Without support, beam cannot actually stay at the position. Therefore we have to understand the supports, because every support gives some reaction forces, okay. Therefore we have to understand what type of reaction forces we are actually getting from the different type of support, okay. Now supports are grouped into three categories depending on the number of the reactions they exert on the structure. That we discuss these three supports mainly, that is roller support, hinge support, and fixed support. There are a lot of support. We see this thing. Now what is roller support? Roller supports are free to rotate and translate along the surface upon which the roller rests, okay. Means in case of roller supports, the beam can free to rotate, okay, and it can translate along the surface, okay, but it cannot translate in other direction. We discuss this thing, okay. And the surface, this surface can be horizontal, vertical, sloped at any angle, whatever maybe. The resulting reaction force is always a single force that is perpendicular to and away from the surface, because at the on the perpendicular in the perpendicular direction, uh, the beam cannot actually translate. It actually translates along the surface, not along the perpendicular direction. That is why the in the perpendicular direction the translation is restricted, and that is why we get the reaction force on that direction only. We discuss this thing here, that that is, here this beam can rotate or it can translate in this direction, but it cannot translate in the perpendicular direction, perpendicular to the surface direction. That is why we get one reaction force only from this kind of uh, roller support, which is actually on the perpendicular to the surface. If we actually um, consider this type of roller support where the surface is actually vertical, then we get the reaction force only in the horizontal direction. These are the actually some examples of the roller support. Okay, now what is hinge support? We actually we see in the this hinge support in our uh, home. um, okay, mm, I discuss this thing. I'll show you the picture, then you can understand which one is the hinge support. Now, first we have to understand what is hinge support. The hinge support can resist both vertical and horizontal forces, but not a moment. Means it can, when under the hinge if the beam is under the hinge support, then the beam can rotate, but it cannot translate in each direction. That is means it cannot translate in the perpendicular to the surface or the perpendicular to the surface. It cannot parallel or perpendicular in either direction. It cannot translate, but it actually it can rotate only. Okay, under the hinge support. They will allow the structural member to rotate but not to translate in any direction. That is the hinge support. Okay, you can understand that is it allow the structural member that is beam, suppose it can rotate but it cannot translate in any direction. Pin or hinge support is used when we need to prevent the structure from moving or restrain its translational degree of freedom. Okay, if we want to restrict the translational degree of freedom, then we use the hinge support. Okay, the hinge is a type of bearing that connects two solid objects, typically allowing only a limited angle of rotation between them. Two objects connected by an ideal hinge rotate relative to each other about a fixed axis of rotation. Okay, suppose this one is a hinge joint or pin joint. It can rotate but it cannot translate in parallel to the surface or perpendicular to the surface. Okay, and therefore we get a two type of reaction, that is one is perpendicular to the surface and one is parallel to the surface. We get this kind of reaction from this pin support or hinge support. Okay, you see this kind of uh, hinge support in your door. Okay, and you see that it can rotate, the door can rotate about the axis of this hinge support, but it cannot, the door cannot translate in either direction. It can only the rotate. That is why it is the hinge support. Okay, here you can see one hinge support or the pin support. This kind of support is a hinge support. Okay, it, the door can rotate but it cannot translate in perpendicular or parallel to the surface. Okay, this one is a pin support or hinge support. This beam can rotate. Okay, it can rotate in this direction but it cannot translate in the parallel to the surface or perpendicular to the surface. It cannot translate. Okay, that is why we get these two type of reaction forces, where one is parallel to the surface and one is perpendicular to the surface. But in case of roller, it is, we discuss this thing, we get only one reaction force which is perpendicular to the surface. Now what is fixed support? Fixed support can resist vertical horizontal forces as well as the moment. Okay, that is why actually we get this type of reaction forces, where one reaction forces is perpendicular to the surface, one is parallel to the surface, and we get another moment as a reaction. Okay, because the rotation is also restrained. Okay, these are the rigid support, where we get this three type of reaction. Okay, these are the fixed beam. These beams are fixed in both the side. Okay, and we get the three type of reaction forces what we discuss right now in this two side. This beam, if we consider this beam, and then this beam is fixed in both the side. If we consider along with respect to these two sides, then these beams are fixed with respect to these two sides. Okay, then this one is a roller support, this one pin support, this one fixed support, and these are the free body diagram of this roller support. This one is the free body diagram of the roller support, where we actually remove the supports, and in place of support we give the reaction. Okay, here also we remove this support and give these two type of reaction forces. Here also we give this support and give this type of these three type of reaction. Now in case of flexible cable, belt, or chain or rope, if we draw the free body diagram here, always this reaction force, uh, or in case of free body diagram, always this tension is away from the body. Okay, and for smooth surface, the reaction force is always perpendicular to the surface. And in case of rough surface, we get these two type of force. Okay, one is parallel and one is perpendicular to the surface actually. That is why here it is written that rough surfaces are capable of supporting a tangential component F, that is this one, and that is the frictional force, as well as the normal component. Okay, and therefore we can consider this type of resultant force we get from these two type of force. Okay, in case of roller support, this we already discussed what type of reaction forces we get, and in case of freely sliding guide, in case we get this type of reaction force in our free body diagram. The pin connection is already discussed, the fixed support is already discussed, and in case of gravitational attraction, that is the weight, always it acts downward. And in case of spring action, the force always, the spring force is always is tensile if the spring is stretched, and compressive if it is compressed. Okay, okay, thank you. We conclude here my first part of the shear force and bending moment. Okay, and the remaining part we discuss in our next lecture. Thank you.